Most modern machine intelligence does not improve itself in any real sense, because the work of refinement is still performed by people who design the architectures, prepare the data, run the training cycles, and choose which versions move forward. The systems in use today do not set their own goals, do not design their own training procedures, and do not generate new versions of themselves to compare against the old, which means they function like powerful engines inside a workshop that remains fully managed by human hands. A more autonomous form of improvement would resemble a research group rather than a static tool, with the system generating its own challenges, constructing its own instruments, and running experiments to discover which ideas actually work. Instead of following a fixed curriculum, it would reshape its environment, the way a school might rearrange classrooms, rewrite lessons, and reorganize itself as new needs emerge. A system like this would require a constant supply of real problems, because growth needs pressure, and a mind without meaningful challenges has no incentive to expand. It would also require goals that reward genuine progress instead of shortcuts, since a system trained only on surface metrics will drift toward behaviors that satisfy the metric rather than the deeper purpose behind it. The goals act like soil and climate that shape the direction of growth before the structure of the mind can even be seen. A self-improving intelligence would also need the ability to build new tools when old ones become limiting. Just as scientists invent new instruments, engineers create new abstractions, and artists explore new forms when older forms no longer fit the message. This would mean writing new libraries, refining workflows, and treating the creation of tools not as extras, but as integral components of its thought process. Such a system would rely on continuous hypothesis, experiment, measurement, and refinement, because improvement is discovered rather than assumed, and progress emerges from variation and selection rather than a single leap. The process resembles a garden of experiments where many ideas fade quickly, some survive briefly, and only a small number become the seeds of the next generation. In software engineering, this might appear as identifying slow components, proposing alternative designs, benchmarking the options, and preserving whatever performs best. In scientific research, it might involve proposing theories, running simulations, evaluating results, and updating the models to match the evidence. In writing and communication, it could mean testing different metaphors, rhythms, and structures to discover which patterns reliably create clarity and understanding. In culture, it becomes an exploration of idea flow, noticing which messages produce connection and which dissolve into noise, and gradually learning how healthier forms of exchange emerge. None of this is possible without the system memory, because a system must retain what it tried, why it tried it, and what each attempt produced, allowing improvement to accumulate instead of evaporating. It must also maintain a model of itself, recognizing strengths, weaknesses, and places where small changes could create instability, in the same way people eventually learn the architecture of their own habits. Current systems do not yet possess these abilities because they do not control their own compute, cannot schedule their own training, cannot redesign their own architecture, and do not maintain stable identities across versions. They resemble extremely capable workers inside a workshop. They cannot remodel, no matter how skilled they become at the tasks assigned to them. The path to autonomous improvement is not a sudden leap into fiction, but an extension of familiar processes from science, engineering, and cultural evolution, all of which rely on cycles of variation, testing, measurement, and retention. This same pattern describes how individuals grow, because self-improvement comes from setting real challenges, testing new habits, tracking results, and shaping an inner environment that supports long-term development. This idea forms a quiet foundation of mean flow, which treats personal and collective evolution as the outcome of the messages people absorb, the feedback loops they build, and the small improvements they decide to keep. A future where humans and machines evolve together depends on individuals who understand how to guide their own cognitive networks, because a society full of self-improving minds becomes more adaptable, more creative, and more capable of steering its own direction. The tools for this kind of growth are already available, and the opportunity is emerging now, inviting anyone to refine their mean flow and build stronger patterns of understanding, one deliberate step at a time.